and we are going to look at and talk about Unit 1, Kinematics, in AP Physics. So in this one, there's really two main topics that can be broken up. We have motion in 1 dimensions and motion in 2 dimensions. And so we want to look at the combination of those things and see what that entails. So in 1 dimension, first of all, you need to know the kinematic equations. You can have those written down, but you need to know how to use them. You're not going to have to derive them, but you may have to derive a function based on a problem, and you have to use the correct formulas and manipulate them to get your answer. So you should be able to use the kinematic equation formulas. I'm not going to walk through which ones those are, but there is a distance formula, there's a velocity formula, there's a acceleration formula, and so you need to know all of those things. If you forget just that you have your change in x, these are the things that it's looking at. You have your initial velocity, you have your final velocity, you have your acceleration, and you have your time. So you're comparing these different things with different equations. Okay? So in a problem, you would have to calculate an unknown using the kinematic equations. One thing that maybe you can do, I'm sure, but you just have to know how to do is calculating the average, calculating a minimum, a maximum velocity. Now to get an average, the average is the change. So an average velocity, for example, is the change in x over the change in time. Okay, and it doesn't really matter how it got there, but it's how much it changed over time. Acceleration average is your change in velocity over change in time. So that's the average. Even if the acceleration and changes, or if the velocity changes, you can use those formulas to get average. To find the minimum and the maximum, you would have, it may be a function or something like that, and you'd have to be able to determine what point is it going to have its maximum or minimum value. All right. Second thing is you need to be able to deal with functions. This is our calculus. There are just really just the principle. You got your position functions change to velocity functions, which change to acceleration functions based on the derivative. You're going the other way around. Your acceleration functions can change to velocity functions, can change to position functions based on integration. So you need to differentiate, which is doing the derivatives, and you need to integrate using the integrals between these different functions. The kind of functions that you would be expected to be able to do: sine, cosine functions, power functions, or exponential functions. You should be able to do integrals and derivatives of those three types of ones. There also may be a velocity-dependent acceleration, and this is called differential equations. For example, let's say that acceleration equals b times v, like this. Your acceleration equals some constant times velocity. So depending upon how fast the velocity is going, the acceleration is going to change. That's a little bit different for you, and your acceleration would have to be expressed in terms of velocity, which is dv dt, and then equals b times v, and you would then need to solve this as a calculus problem using functions. So we will cover that later. And then also in 1 dimension, you need to be able to do graphs. So we have position versus time graphs. We have velocity versus time graphs. We have acceleration versus time graph. You should understand what those kind of graphs are saying. If it's a linear, or if it's exponential, or if it's decreasing, what is it saying? And you should be able to translate between positions. You should be able to draw velocity of that. if you're given velocity, you should be able to draw an acceleration graph for those. Things you may be asked to determine are your intercepts. So when does it intercept the x or y, and what does that mean? Asymptotes is when it gets closer and closer and closer to 0. Area, find the area under the curve, that's integration. Slope, tangent, that is your derivative. And so you should be able to identify all of these things using graphs. Right? In 2D, we're really dealing with vectors. And so you need to be able to understand how to do vectors. So kinematics in 2D, you'll have to calculate the components. So for example, you would need to, if you're going to do a velocity vector, you would have to figure out what the x part of that velocity is, what the y part of that velocity is. You may see it in terms of x and y, or you may see it in terms of I and j. I is x, j is y. And so you have to be able to understand those components. So you take a vector and break it into components. That is using sine and cosine. The x velocity is, I'll just do this one and you can figure out, is your magnitude of velocity times the cosine of the angle at which it's traveling. So you have the trig identities that you're going to have to use to figure those components out. Then you will have to resolve them to bring all your x and y's back together to get a final magnitude and direction. And so your final magnitude is the square root of your x squared plus your y squared, and using Pythagoras theorem. And then your tangent of your angle is the y over the x over the x. And so you should be able to manipulate vectors with those things. Add, subtract vectors, determine average with the vectors, and all of those things. So those are things that you will need to do with 2D vectors. And then if you need to deal with kinematic equations, you should know that if you're going to do kinematic equations, you still have the same kinematic equations as x, but you have a x set and you have a y set of kinematic equations. And where x set, you have vx's, ax's, and in the y set, you have vy's and ay's. You solve those separately, and then in the end, resolve them back together using your trig identities. You also would need to be able to do this with calculus. So know that you got an x set of calculus derivatives and integrals, and you have a y set of calculus derivatives and integrals. Solve each one separately, and then resolve them back together. In the end, doing the exact same thing. So, and then 2D motion, the graphs, position, velocity, acceleration versus time, you would need to know those. You just would probably separate the x and the y part to describe those. All right, and then finally, probably one of the most major examples of 2D motion is projectile motion. So you should be able to do projectile motion and understand it and solve that using the right kinematic equations. Your x is not have acceleration unless there's air friction, and your y does. And so you need to know how to use those. Horizontal launches is where you're at a height and you launch it straight sideways and it comes down. An angle launch, it goes up and comes down, or you could have, and you have to determine the range, or you could have even something that starts on a hill and then it shoots up at an angle and comes down. That is the most complicated because you're going to have to use the, what is that called? The b equal, or y equals b plus or minus, b squared, that thing. You'd have to use quadratic formula. All right? So that's 2D motion with kinematics. And that's it. So hopefully we can spend some time working on examples of those.